Hello, everyone. This is part 11 from the Precedence Networks chapter. And here we're going to look at some examples and test our understanding on the entire chapter here. So I asked you from on the previous lecture, actually, to pause the video on some logics behind these three activities. So the first one is when you have an activity A and B, duration 10 and 8, and you have 4 lag for start-to-start relationship. Is this relationship logical? Then I want you to pause the video and tell me if you're going to have an early start of 0, what will happen here? Then if you are going to do so, it's going to be 0, duration of 10 with a lag of 4. Then B starts off 4 with the duration of 8, it gives you 8, it gives you 12. So then start-to-start relationship, it's logical. Now what about this one here? Same logic, you started from 0, day of 0. Is it logical or not? Then to bring in dates, we have 0. Let me bring in the laser pointer here. We have 0, duration of 10, lag of -6, which is 4, right? 10 minus 6, 4, with a duration of 8, then it's a 12. So for a finish to start relationship, it's logical. Then what about this one here? Finish to finish relationship. Again, you start from 0. Is it logical or not? Bringing in the number, we have 0, duration of 10 is 10. Then the start here is 4 with the duration of 8 is 12. But then finish to finish is the 12. That means both they have to finish in the same day. Is it logical? In some situations, I think yes, but in a lot of situations, not necessarily. Finishing 2 activities both in the same times if they have some critical elements that could be installed and need recheck, or you need kind of a grace period to make sure that, like in a case of laying the utility line, you need to finish the subbase before laying the pipe completely, right? So let's work on some quizzes here, true and false. Precedence networks are another type of error networks, true or false? Well, actually, it's false because precedence networks are another type of networks, not necessarily just error, could be not an error. Second question is the precedence networks allows for overlapping activities, true or false? The question is true. The stair type relationship results in less number of activities than in the precedence activities. Well, it's false. Because if you remember the stair type of relationships, it's actually break down activities into multiple sub-activities. Fast tracking a project can be shown better in precedence networks. Yes, correct. And then converting the type of activities from contiguous to interruptible may result in longer project duration. I would say yes. And that's why we have to work on the contiguous first, then we bring in the interruptible to adjust the schedule. Let's work on more problems here. If A, B, and C are 3 activities connected with the start and finish combination relationships with no lags, their durations are 5, 10, and 3, respectively. What is the duration of the project? And I'm giving you here 4 options. Now I want you to pause the video and tell me what is the duration of the project here. And just to give it away, the solution is D, 18 days. Let's work on another example. If we have A, B, C, three activities connected with the start and finish combination relationships with 2 days lag on each relationship. Their durations are 5, 10, and 3 respectively. What is the duration of the project? And I'm giving you here projects. So I want you also to work on this, pause the video and tell me what's the duration. And the solution is 22 days. Let's work on another example here. What does the relationship mean to you here? Looking at it, we have activity A with a lag of a 3, start to start with activity B. So what does it mean to you? Is it activity B has to start exactly 3 days after the start of A? Activity B can start at least 3 days after the start of A. Or activity B can start at most 3 days after the start of A, or none of the above. So which relationship or option is the correct one? Well, again, look at it and answer it, and the answer is A. Because activity B has to start exactly 3 days after the start of A. How about this one here? Activity B has to finish exactly 3 days after the finish of A. Activity B can finish at least 3 days after the finish of A. Activity B can finish at most 3 days after the finish of A, or none of the above. And again, the answer is activity C, which is activity B can finish at most 3 days after the finish of A. Now, how about this one? What does this relationship mean to you? Activities A and B must start simultaneously, but B has to finish exactly 2 days after the finish of A. Activity B can start after the start of A, but has to finish at least 2 days before the finish of A. And activity B can start before the start of A, but has to finish at most 2 days after the finish of A. And lastly, activity B can start after the start of A, but has to finish at least 2 days after the finish of A. And the solution is A. Activities A and B must start simultaneously because we have the start-to-start relationship, but B has to finish exactly 2 days after the A because of the lag. And for this relationship here, activity A can start 2 days before the start of activity B. Activity B can start 2 days after the completion of activity A, and activity B can start no more 2 days before the completion of activity A, and activity B has to start at least 2 days before the completion of activity A. And the solution is D. Activity B has to start at least 2 days before the completion of activity A, and that's the solution. So with that, I concluded chapters 5 for you. And thank you. And we'll go on the next chapter, which is 6 later.